All right, so arithmetic sequences is a series. By the end of today, you'll be able to write formulas, find sums, and identify patterns. Okay. This is the second half of numbers and algebra, so it's like an extension to the basics that we talked about in the very first section. Okay. So a sequence is a list of numbers that obey a certain rule. Okay. Is a list of numbers that obey a particular type of rule. This rule could be anything from recognizing that each number increases by 2, or is anything from noticing that you start with a triangle, then you go to a square, then you go to a pentagon, then you go to a hexagon. So you're adding a segment every time you create different shapes. That is what a sequence is. Okay. More specifically, a list of numbers is what we're going to be dealing with. No shapes here. That's geometry patterns. Okay. Now, each number in the sequence is called a term. So when I refer to different things like, what is the 12th term of the sequence, I'm talking about what's the 12th number in this line or in this list of numbers. Okay? Now, an arithmetic sequence, more specifically, is when you're either adding or subtracting the same number from the previous term. Okay? Adding or subtracting the same number. And that number that is being added or subtracted is called the common difference D. Now, the reason why I only have added there versus added or subtracted is because your common difference will either be like a positive 3 or a negative 3. So you're either going to add 3 or you're going to add a negative 3 every time. Okay? When it's referred to, it's usually you're adding your common difference, whether it's positive or negative. So your common difference can be positive or negative. But you never say you're subtracting 3 from each term, you're adding a negative 3. Okay? Terminology wise. Your first term in sequence is represented by U1. The second is U2, and so on and so forth. Okay? So they could ask you in words what is the first term, or they could just say find U1. You need to recognize that that means the first term. All right? Questions up here? All right. So here we go. We've got a couple of different examples here. Okay? What is U1 in the first one? It is 2. It is your first term. And 10 would be represented how? Okay, as the fifth term in the sequence of numbers. What is D in this problem? D is a positive 2. That is what you're adding each time to the previous term. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So on and so forth. Over here, what's U1? 3. What is D? 0.5. You're adding 0.5 to each term. 3 plus 0.5 is 3.5. 3.5 plus 0.5 is 4, so on and so forth. For the third one, what is D?
Negative 3.
Negative 3. Okay, remember, D can be positive or it can be negative. So basically, you're adding a negative 3 each time. Okay? 1 plus a negative 3 is a negative 2. Negative 2 plus a negative 3 is a negative 5, so on and so forth. And for the last one?
Negative 0.1.
Negative 0.1. Okay? You're basically adding a negative 0.1 to each term to get the next, okay? Now, one thing, yes? So 3.5 would be U2, yep. And in this case, negative 5.4 would be what for the last one? You said 5, okay? So that's what they're talking about. What place, or what is the fifth term? What is the fifth number in that list of numbers, okay? Now, there's a formula to go about figuring out the nth term. So any term in an arithmetic sequence, and that formula is listed right below. U sub n equals U sub 1 plus n minus 1 times d. Now, you don't have to memorize this formula, but you do need to know what each thing means, because in your reference booklet, it just gives you a formula. It doesn't give you what each of those things mean. Okay? So U1, of course, represents your first term. So in like that very first example, it would have been 2, and 3, and then negative 5, so on and so forth. N represents your number of terms. Okay? So the problem might ask you to find D is your common difference, so that number that's being added each time, whether it's positive or negative. And then U sub n represents the nth term. So if it asks you to find the fifth term, you know your number of terms is 5. You're looking for that term in the sequence. And then, you know, what is it? What actually is it? What's the number? It's not going to be 5, but, you know, it's in the fifth spot. And you can always find D. You can always find your common difference by subtracting a term from the previous one. Okay? So U sub 2 minus U sub 1 will give you your common difference. U3 minus U2, common difference. U4 minus U3, common difference. That is also how you show that something is an arithmetic sequence. Does everybody understand that? You might get a problem. They'll say, show that this sequence is arithmetic. And you can't just draw a line and say, no, this is plus 3 plus 3. You have to actually show the subtraction of the terms. Not just one, not just the second minus the first. Not just the third minus the second. However many terms they give you, you need to show that consistently. So let me show you what I mean by that. Okay? If the problem says show that number 3 is arithmetic, okay? Well, you're not going to do this, okay? You're not going to say, oh, well, this is minus 3, minus 3. You're not going to do this, okay? That will get you no points. All right? You would actually have to do negative 2 minus 1 is negative 3. Negative 5 minus 2 is negative 3. Negative 8 minus 5. Sorry. Yeah. Minus 5 is minus negative 5. Hold up. Negative 13. There we go. Yeah, sorry. Minus a negative. Minus a negative 2. Minus a negative 5. Negative 3. Negative 11 minus a negative 8. Keep change flip. Every single one. Does everybody understand that? If you did these 4 and you forgot the last one, you would get no points. Okay? That's how you show. And I doubt that I actually give you 6 terms. That might give you only 4, so it won't be that much. Okay? Does everybody understand that?
You have to show how we have to do.
Yes. Because, I mean, they'll tell you, like a lot of times they'll say, show that the common difference is negative 3.
Oh.
So it's already given to you. You actually have to do, like, the algebraic processes to get negative 3. I mean, they probably will be easy, but you have to show it. You still got to show it. And you can't do the whole, well, it's negative 3. Like, you actually have to algebraic do it. Does everybody understand that? There's some method points right there that you can easily lose if you don't show. Okay. All right. Awesome. Did that. Let's look at an example. Here's a sequence of numbers 2, 5, 8, 11, 14, so on and so forth. Show that the sequence is an arithmetic sequence. To be an arithmetic sequence, that means you're doing what? Adding, subtracting. The same number each time. So how do you show that?
You show 17
Mm-hmm. You show it. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11, 3. 17 minus 14, 3. For anybody that's watching this video now who's not in class, you're probably like, do I really have to do that? Yes. Yes, you do. If you want the points, you'll do that. But if you can go without, 2 points, by all means, you don't have to do it. But I mean, you probably get as many points as you possibly can. All right? Plus, look at B. B says write down the common difference. If it ever says write down, that means the answer is staring you in the face somewhere on the page, in the problem. What is the common difference? 3. You just did it 5 times. That is the common difference. Okay? No work is needed there when you have to write down something. Does everybody understand that? So not only am I kind of going over arithmetic sequences and series, but I'm also kind of showing you some terminology that's used on test. Okay? Write down, answer somewhere like on that page. Okay? Like staring you in the face. Write down the 10th term. Well, yes, you can sit there and you could do 17 plus 3, that number plus 3, that number plus 3, until you reach the 10th term. But if it says 25th or 100 or 263, you are not going to sit there and waste precious time and add 3 all those times. let alone, heaven forbid you lose count, right? Or you misinterpret, like the first one is not really the first one, it's really the second one, or something like that. You start second guessing yourself. Use the formula. Use this formula. To find the 10th term. What are you going to plug in for U1? No.
Oh, I think.
2. What are you going to plug in for N? 10. Because if you're looking for the 10th term, that means that N had to be 10. What's D? 3. And you're looking for the 10th term. So you're looking for U sub 10. You do that out, and you find out that the 10th term is 29. Do you have to show out all your work? No. No, you don't. But if you want to get your points, yes, you should. Okay?
I was like,
Let's find the 25th term. You guys do that. Do that right now. Find the 25th term. So for D, you'll have U sub 25 equals the first term, which is 2, plus 25 minus 1 times 3. 2 plus 24 times 3. And you got 74. Question. All right, let's look at a different one. It says the second term of the arithmetic sequence is 1 and the 7th term is 26. Find the first term and the common difference, and then find the 100th term after you do that. Now this one's different than the other one. You don't have your first term, and nor do you have two neighboring terms to figure out the common difference by subtracting. So how do you do it?
Plug it in.
What do you mean plug it in?
That equation, like, and you'll just leave it +1 instead of that.
Okay, I think I might need you guys to talk this out as I write it. So, go. Maybe.
What?
You said plugging into the formula. I'm like, okay, how?
Yeah, so you take, yeah, sure you can. You go, you use 26 as your U7. So you say 26 equals U1 plus, I don't know, what's the rest of the formula?
N minus 1.
Alright, so
That's why you can't plug it in.
what term is it? 7? 6? 6 times, what do we got out there? D?
You
don't know.
You don't know
Well,
any
put it out there.
Well, I mean, this is very good to help you figure out your first term, but you need to know your common difference, okay? So yes, to find your first term, you're going to use one of your terms, and you're going to plug that in for U sub n, and you're going to plug in the 7 for n. But you're right, we do need our common difference. There's 2 ways you can do this, okay? I'll show you the way that if you have Miss Children's for Algebra 2, she would have taught you that I don't like, and then I'm going to show you another way, okay? So, you know the formula is this. To figure out your common difference, you are going to temporarily make your second term your first term, just temporarily, okay? So U1 is going to be 1. Now, it's no longer the second term. 1 is now your first term, okay? Is everybody still with me? Now, when you do that, that's going to change your old 7th term. That's now going to turn into your what term? Your 6th term, okay? And you're going to use these numbers temporarily, and you're going to plug them into the formula, okay? So my U1 is 1. I'm going to plug in 26 for U sub n, and then I'm going to plug in 6 for n. And by doing that, you're able to figure out your common difference by basically pushing the terms down until one of them is temporarily your first term. But you got to do that all the way through, okay? What's 6 minus 1? So you got 26 equals 1 plus 5 times d. How do I solve for d? Subtract 1, and then, which is 5. So d equals 5. That's the way that Ms. Schultz would have taught you guys back in Algebra 2. I personally don't like it because what if the number is like further down the line? What if it's not your second term? What if it's like your 7th term? You push it back to your first term, and then you push the other term back too many times, and you done messed up. Okay? What I like to do It's kind of with the old school way of like, okay, saying this is your first term, then 3, 4, 5, 6, 7. Okay? It's kind of doing something like this, a little old school, okay? Like the drawing is what I see in my mind when I do this. Basically what you do, you take 26, you minus it from 1. Okay? And this works every time. So you do 26 minus 1. You take your two terms and subtract them. And then you divide it by their placing. 26 is your what term? And 1 is your what term? The second. What's 26 minus 1? And what's 7 minus 2? Which is? Okay? So basically, you subtract the numbers themselves and you divide them by where they're placed in the sequence. So 26 minus 1, which was your 7th term minus your 2nd term. And that's how you figure out your common difference. That's how I do it. Okay? And you'll get it every time with the arithmetic sequence. Okay? So if our common difference is 5, so d equals 5, we can plug in this formula that Andrew already set up for us and figure out that our first term was 6 times 5.
30.
30. Subtract, and our first term is going to be negative what? And that's part A. So again, to find your common difference, you can do it by pushing the numbers down in the sequence and using the formula, or you can do
Because we got, the first, we would have to do that one formula, we just subtract one, or, yeah.
because you could subtract 5 from 1, but if it's not the second term, you would have to do that too. I want you guys to find the 100 term now. Do that now. So your 100 term, what you guys get? 491. So you plug in 100 for n. Your first term is negative 4 plus 100 minus 1 times 5. What's 99 times 5? 494. 495. You subtract that and 4. 51.
So it's not 44, it's 4.
It's just 4.
Oh. Sorry about that. Questions? Here's a sequence of numbers. Compared to the other one. What's different? You're getting the end, but you don't get the middle. Anything else? You don't know their places. Well, we do know the first 3, but that last one, we don't know, do we? Okay? But we can figure out our common difference. What's our common difference? 4. And you see how it says write down? It's right there, right in front of you. Didn't ask you to show, it just said to write it down. So it's a positive 4, and then you have to find the number of terms in the sequence. Use the same formula. Same formula for arithmetic sequences. What do we not know? What variable do we not know? We do not know n. But we know d is 4. We know u1 is, and what's use of n? 50. 50 is that last term. 50 is the term we're trying to figure out that it is. There's some other numbers in between. That's what the 3 dots represent. But we're trying to figure out exactly how many terms the sequence has, because 50 is the last one. So then we just solve it like a regular equation. What do you do with the 4 and the n minus 1? Okay, that's one. Okay, that's one way we do it. Subtract 6, which will give me what? 44, and then divide both sides by 4. So you'll have 11 equals n minus 1, and then add, which is 12. All right, someone say wait. What happened? thought I heard someone say wait.
No, that's it.
Okay? This is one way that you can do this. You can subtract 6, divide by 4 since you are multiplying, and then just add 1 at the end. Another way you could have done it is by what? So you're going to do it this way every time?
Wait, so it's why doesn't it multiply now?
What do you mean?
Why isn't it 4 and you subtract this in
4? Because when I was asking how to solve this, that's what one of your classmates said, and I just went with it.
it.
That's what I was asking. Do not leave yet. I am not done. Okay? And you'll be fine.
That's what I'm saying. God bless you.
Not here.
Another
Yeah,
way, since no one wanted to answer my question,
Morgan Barrera to the front office, please.
another way that you could have solved this problem was at this step to distribute over. You could distribute to get 4n minus 4. Okay? You could have combined like terms to get not 10. 2 plus 4n, subtracted 2 from both sides, and then divided by 4. So you still would have ended up with the same answer of 12. Okay? Yes? I messed up. I put 10, it should just be 2 plus 4. Okay?